this is what we're going to do. Mathematical modeling. What is that? What is mathematical modeling? Can someone tell me what are you doing when you're modeling something mathematically? Could be a visual representation. Could be a graph. Displaying what? Displaying what? Math. Okay, that's awesome. Can you be more general? You're displaying a function. A function of what? Data of what?
Questions.
Data of what? From where? No, usually we're using the data to generate the function. So what is the data we're talking about? What data are we talking about? What would you like to model? Something from...
Like the economy.
What would you call that kind of data? Something from the...
Real life.
Real life. Real life. I'll use your words. Describing real life situations with math. Yay. The traditional way we do this is by taking a set of data and writing an equation based on that set of data that models the data. What does it mean to model data? What's it mean to model the data? To demonstrate it? Well, how would you know if something doesn't model the data?
It doesn't match.
Well, yeah, it doesn't match. These are all subjective words, right? Well, what does that mean exactly, though?
You can't read data from here.
Well, for example, let's say I had a data set that looked like this. You know, let's say we graph something. What would this be called? You've seen these before. And I said, okay, this models the data. Why not?
Because it's not the line of best fit.
It's not. It doesn't look like the line of best fit. I like that. The function doesn't follow the, I like that word, trend of the data. That's true. Here is a nice definition that I like. Can you read that out loud, Mr. Solnit?
A mathematical model is a mathematical description, often by means of a function or equation, of a real-world phenomenon such as size of the population, the demand for a product, the speed of a falling object, concentration of a product in a chemical reaction, the life expectancy of a person on Earth, or the cost of emission reductions.
Are there quite a few things you could model from real life?
Yes.
Yes, there are quite a few things you could model. So what's the point? Why? Why do we model? Why do we come up with a model for a set of data? Why? What's the point? Someone raise their hand. I want a sentence other than a noun. Just give me a sentence. Yeah? To predict the future. I like that. Or what? Not only predict the future. What else? Does it have to be the future?
To understand or express trends.
Trends, yeah. I mean, it could be the future or it could be between 2 points. There's extrapolation, and then there's, what's it called when you're trying to guess in between? Intrapolation? I'm writing that down. That's great. Extrapolation. We're going to call that. No, we can't call it that. It's extrapolation. Intrapolation. That's excellent. You ever seen the New York Times piece where they have people like make up words? Usually it's like changing one letter, or you can take two words and put them together and make a new word. And usually the made up words are much better than the words that exist in like real life. It's interpolation. I like yours. That was much better. I mean, I expect good things from poetry people, so. You can predict, exactly. Can someone give me one situation where it'd be useful? Let's say you had to give me a set of data that you could take and then analyze and then use that to come up with a useful conclusion. Yeah, let's go with Danilo and then Andy. Yeah.
You get certain data in the 20th century.
Yeah.
You want to know how it reflects in 2010.
Exactly, yeah. Very good, very good. You could use past data to figure out what's going on right now or predict the immediate future by looking at the past. What else, Andy? Stock market modeling. You want to talk about the king of all modeling that people obsess over. Stock market modeling, absolutely. Is that crazy stuff? Is that way more complicated than anything we're going to touch in this class? Absolutely. Can I give my little aside about stock market modeling? This is my little aside about stock market modeling. Okay, so you play the stock market. Why do people invest in the stock market? What? To earn money. That's the basic motivation. Assuming people are normal, usually people, the majority of them who play in the stock market, want to earn money. They don't want to destroy things, although you could make the case that people actually want to do that considering what has happened to the stock market recently. So people want to make money, right? How do you make money in the stock market? You buy and sell. You buy low and sell high. Now you do that, you get better and better at that if you know what? What do you want to know? What's going to happen? You want to predict where the stock is going to go. If you can predict where stock is going to go, you can make money on stock that's going down, going up, right? There's ways to do that. Here's the deal. The better you are predicting where stocks are going to go, the more money you make, right? What happens if you get really, really good at it? This is kind of like my joke of the day, and I'll get more of them. This kind of gets me riled up. What happens if you're really, really, really good at predicting where stocks are going to go? There's two things that happen. One of them is way more popular than the other. What's one of them? What's one thing that happens? What happens if you're really, better than anybody at predicting where stocks are going to go? Oh, wait, you all said the same right thing at the same time. What'd you say there, Cochran? Think about it. If you're good enough at it, think about it. There's a term for it that you hear. Wall Street, the movie. It's totally illegal. It's called insider trading, right? So basically we have a system that's set up to push people to know as much as they possibly can without passing this arbitrary moral line in an institution that is completely, I would venture to guess, morally corrupt, right? So if you're good enough at it, you go to jail, or in that rare circumstance where you don't have to, quote-unquote, break the law, or you know how to abuse the law. It's such a weird system when you think about it.
And I think
very strange.
It's also weird because if you suggest that a company is going to go bust, basically everyone will sell their stock and
based on that
will
go bust, yeah. So what was the causality there? What was it going to go bust?
Someone said it was going to.
Well, prove it. Who knows? You can't test it. You can't go back in time and reverse the rumor, right? It's really weird. And here's another thing to think about. Do you know how much money was lost, just evaporated in the global, the U.S. stock market crash? Our estimate, how much money just disappeared? I mean, money disappeared. Stuff that was worth something no longer was worth anything. AIG, poof, right? Do you know how much money disappeared? Billions and billions of dollars, right? People did nasty, nasty stuff. Here is your first homework assignment. This is made up on the spot. What is the maximum prison sentence imposed on someone involved with the recent U.S. stock market crash? Prison sentence. How many years? What's the maximum prison sentence? Find it for me. Find it. Find me the person who was put away for life for a white-collar crime. Find it.
You just told us it
What?
was life.
What?
You just told us it was life.
I just told you it was life. I'm saying it. What?
Never mind.
It's not, okay, I'll tell you this. It's not life. Bernie Madoff is going to prison for 10 years, and he evaporated $700 billion, $400 billion, right?
It's got to kill someone somewhere.
No, I'm telling you, find me the maximum prison sentence imposed by a court in the United States. So, here's modeling, right? This is awesome modeling. Love this stuff. Love this stuff. I have no idea why I didn't get into this business earlier. It's amazing. Do you know how the markets are doing right now? It's a great time to be a banker. There's money. They're still making money.
There is a group of people that just does long-term investment, where they invest in stock and make dividends.
Yeah, in a million different ways. Yeah, absolutely.
So if you become good, you become legally suspicious?
Absolutely.
Are you
Absolutely. Absolutely. You are absolutely legally suspicious anytime you're making a ton of money in the stock market. Absolutely. Okay, I had to pause this. Absolutely. Has anybody seen graphs that look like this before? Biology? Okay, what's this? What's that represent right there? If that's a population growth curve, what is that yellow horizontal line?
Maximum population.
Something capacity, what? Yeah, maximum capacity. It's also called the, begins with the C. The carrying capacity. Who knows about that? What is the carrying capacity? It's the
largest number of that organism can be supported by the environment.
yes, max population supported by an environment.
Is that, like, when you go over that has problems, like, what, say, in Pennsylvania with the deer, I believe?
Yes, absolutely. There's lots of small examples of this. Absolutely. So, I mean, there's humans, populations here, any environment. You look at an environment, there's a certain carrying capacity. There's enough resources to support a certain number of those organisms. Okay? So we have data on population growth. What could we do if we have some data on population growth for a country over a period of time? We could create a model. Okay, good. Okay, that was subtle. We could create a model, and what could that model help tell us?
When we'll hit maximum.
Well, finding out what the actual carrying capacity is a rather complex thing to do. But if we figure that out, we could use the model to predict when we would hit the carrying capacity. Is that a rather important thing to predict?
Yeah.
Why also, besides carrying capacity, why also would it be important to predict populations? How do we allocate resources, right? Town planning, city planning. What resources go into population centers? I mean, there's food, right? There's like the actual energy to live, but then there's police and fire and schools. You know, these are huge things that cost a lot. Healthcare, right? So would modeling be rather important in these types of fields? Absolutely, absolutely. Life expectancy models. There's a field that is almost entirely devoted in the math field to figuring out life expectancy models. If you do this, you are called something, and you make a lot of money because you are working for the what industry? Nope, not generally, but I'm sure there are. And your insurance agencies. You know what this job is called?
No.
How does insurance work? You pay money every set amount of time so that you are protected against a certain calamity, right? Car insurance, house insurance, life insurance, health insurance, right? So the insurance companies need to figure out how much to charge, right? So they need to know what? They need to know very, very good statistics on how long you're going to live and what types of things are going to happen to you, right? Does anybody know what these people... So are these people kind of important inside the insurance business?
Yes.
Without the numbers, can the insurance companies figure out how much to charge? No. Game over. Is it actuary? Has anybody heard that term before? Actuary. If you ever want to make a lot of money, become an actuary. It's a lot of money in being an actuary. People like doing it. It's the kind of thing you either love or you hate.
Isn't it sort of morally...
No, statistical analysis. I mean, no. It's what's more. I'm sorry. What are you saying? The actuary is statistics aren't evil. Facts aren't evil. What people do with them could be evil. What people use.
Life and telling him when they're going to die and how it's going to happen.
That's not what they're saying. They're saying things like, if you live west of the Mississippi and you're a Caucasian male between 55 and 60 and you smoke, you have an average continued life expectancy of 26.9 years. Therefore, we know to charge you $78 per week for health insurance. That's what they're not. It's all strict, but the point is, I don't argue that the insurance industry is crazy, but the actuaries, they're just statisticians. Every major corporation on the planet has someone like an actuary working for them, or many actuaries working for them. Data analysis is huge. If you want to make a lot of money, actuaries or algorithms. We might have really powerful computers, but we have to tell them what to do. If you want to make a ton of money, become an algorithmic programmer. Ooh, good stuff. Anybody read Wired magazine? Anybody seen Wired? A couple months ago, it's like the New York Times of technology, so it's not that crazy. They had an article on the International Programming Olympiad, how these kids are jumping straight into elite graduate programs as going straight from high school to MIT, but going into 5th level programming classes, and then getting their degree and going straight into $1 million salaries. Okay, what are the biggest tech industries right now? Apple, to this, briefly. If I gave you this right here, How comfortable would you be if I just said this? Are you all deeply familiar with this statement right here? Yeah, what is that? Yeah, please use this, okay? You do not have to be forced into using slope-intercept. You do not have to. Now, what about a real-world problem? How about we do a nice, simple one? Well, first we look at that. I like that. We'll talk about this first. So if you had a real-world problem, you could formulate a mathematical model. Once you have a mathematical model, you could you could determine a mathematical conclusion. From your conclusion, you can make you've already said this, a prediction. But then that prediction could lead you back to so for example, we could use some data, predict population growth. We could then figure out that we're going to hit 12 billion people in 2100, whatever, right? But the predicted carrying capacity of the planet is 10.5 billion. So what's our new problem? Yeah. If you zoom in on those population growth curves, you see this generally. There's basically 3 phases, and I'm overgeneralizing extremely here. What are the 3 phases? Yeah. Do populations know, like, oh, we're getting to the carrying capacity, we better slow down? No, humans are dumb, especially, right? Humans are dumb, but no population knows, right? But what happens? Eventually, you get to this plateau, and well, no, yeah, yes, you live and then you die. You live and then that's true. What's the change that's happening at this point? No, not what specific event. There might not be a specific event.
It's the population's
why though? What rate is now?
The death rate is greater than the
birth rate. Exactly right, and then it equalizes. Sometimes it crashes back down, and then the population goes out of existence. But at this point on the planet, on Earth, what do you think will lower the population? Hunger. Okay, let's talk about that for a second here. War? Possibly. There you go, 3:30. Number one resource that's going to be in competition? Water, everybody. Danilo, hi. Andy, hi. Water. And not enough for everybody. Diseases are produced, yes. Despite global catastrophe of pharmaceutical or... Yeah, I agree. It's totally possible. I agree. End of the world type stuff can definitely happen, but I'm talking about in a normal situation. I do have...
I'm just talking about recent viruses.
Recent viruses, yes. Those are great books to read, and it is certainly possible. Absolutely. Anyway, water. What other resources are we talking about that would limit a population? Food. Here's a good thing. Not a good thing, but a thing to talk about. What's the number one thing humans could do if they wanted to increase the carrying capacity of the Earth? It's a behavior that we would have to change regarding food.
Eat less.
Eat less. Okay, eat less, eat locally, but something bigger.
Vegetarian.
Yeah. What would happen to the global carrying capacity if everybody on Earth became a vegetarian?
It would go up.
Increase our carrying capacity by, what do you think?
A lot.
A ton. A ton. Has anybody...
Well, you don't
No.
want that. We
More
don't want
cows?
that.
What?
If we didn't eat them, then they take up space.
Well, but if
You'd stop breeding them.
Why would we continue? We wouldn't. Okay, if everybody. Okay, if we were all vegetarians, we probably wouldn't have the super farms in the Midwest where they have like 10 million cows living on like a dime. You can look these things up, but like an acre, they have calculations like, how much space it takes for one cow to live, right? Like how much land that's devoted to like one steer, as opposed to how many people you can feed on that same amount of land, and the ratio is huge. I mean, it's like 80 to 1 or something. Also but that's just food. What about the environmental impact of raising beef as opposed to wheat? It's enormous. It's in South America, raising cattle is a major source of what? Reason for what? Okay, emissions, but what else? Yes, but what else? Rainforest deforestation, absolutely. Hundreds and hundreds of acres per day, thousands of acres per day are clear cut so that you can raise more cattle. And what happens to global temperatures when that happens? It increases, less CO2 cycling through the atmosphere. Do you know why the Sahara is so large? What civilization is most responsible for the Sahara expanding?
Egypt.
China's over there, Sahara's over here. China's really big, but they're not that big. Egypt? No. No.
France.
Nah, it was yeah, technically Europeans, yeah. 2,000 years ago, who was real big in Europe? Rome. Was Rome in North Africa? You know what Rome did a whole lot of in North Africa? cut down a lot of trees. And do you know what happened to Sahara during the Roman Empire?
Expand.
Huge expansion. Huge expansion because of the Romans. Huge expansion. If I gave you this question, if we wanted to do something real simple, let's start with 2 points. And we'll talk about atmosphere. I think we can talk about atmosphere. I think that'd be a good thing to talk about. Right here. Here's this question right here. So, dry air moves upward, it expands and cools. If the ground temperature is 20 C and the temperature at 1 kilometer is 10 C, express the temperature T in Celsius as a function of the height in kilometers, assuming that it is a linear model. Draw a graph, and then what is the temperature at 2.5 kilometers? Please do this now on your own. Who would like to give me a function T of H? You can only use T and H in your function. What's temperature in terms of H? Yeah.
-10.
Negative 10 H plus 20.
Negative 10 H plus 20. Who agrees with that? Sure. So you end up with a graph. Looks roughly like this. Different scale. I know you don't like that, but that right there is 0, 20. This right here is going to be 1, 10. So there's your graph. What's the temperature at a height of 2.5? What do you do? Yeah, it's going to be T at 2.5, negative 10 times 2.5 plus 20. And you end up with, so at a height of, if it's assuming it's a linear relationship, it's going to be -5. Okay, that's great. What happens if we make it a little more fun? We start with this. Population. All right, carbon. These are good topics. Could you analyze that table of values by hand if you really wanted to?
Yes.
What would be the one thing that would be annoying about doing that? Someone raise their hand, I'll call on you. What's one annoying thing if you had to do that by hand? Yeah. Decimals are annoying, yep. What else? What's annoying?
Large numbers.
Large numbers. They're close together. So if you were, what's the first step in making a scatter plot? You have to plot the points. So it would be pretty hard to plot the points. What are we going to use instead? Please enter that data into your calculator as a table of values. And the one thing I want to say is this. Please don't call it 1980. Call it 0, 2, 4, all the way up to 18, okay? Doesn't change anything functionally, but it makes it so your calculator isn't quite as cranky. Final product. I want it to look like that. You end up with something like this. Kind of looks linear. How do I come up with the linear regression for this? How do I do it? What do I press? Someone walk me through it. Raise your hand. Stat, calc,
Linear regression.
4, and I press enter, and it tells me that model. If I want to graph that, how do I get that to get graphed? I could copy down all the decimals. That's annoying.
Bars.
Ah, vars, yep.
Then statistics.
Where's
Statistics.
Oh,
EQ.
Reg EQ, if you do that. Oh, did I do it wrong? So I need vars, y vars. No, what is it? Statistics? EQ. It's a lot of button pressing, right? For some reason it's being cranky. Oh, you have to go to y equals and do this. Okay, vars, stats, EQ, reg EQ. Okay, that's nice. It's a lot of button pressing. Here's an easier way. If I clear this out, well, if I go up, if I clear this out and I go back to the main screen and I run my regression, but then while I'm doing that, I put a y1 right next to it and I press enter. Look what it automatically does. If you put y1 right there or y2, it'll put it in that position. That's the quickest way I know of to do that. Now when I graph this, what should I see?
Will that show up on the YouTube video, or does it only show up what's on the graph paper?
It would not only get everything that's on the screen, it would get everything you just said.
See a linear function.
Like an internet.
So if we graph that, why isn't it turning on? Oh, anybody know what? Well, it doesn't seem to like this. There it is. Sorry. Does that look pretty accurate?
Yeah.
Okay, so now that we have a model for that data from 1980 to 1998, put your calculators down, hands up. Thank you. Calculator, hands up. There we go. This is where I pump the brakes. What could I use this model to predict? This is the future, or from this data set, what is the future for this data set? Now. So if I go back to my main screen, and I do vars, y1, if I pick y1 and I do comma or parentheses 30, what am I doing?
Going 2000.
What was your 0 on our table?
1980.
80. So what's your 30? So I press enter on this, it's going to tell me parts per million of carbon in the atmosphere. That's what this model predicts. And the thing is anybody on parts per million currently?
350 is the goal.
389. 350 is the goal. That's correct. It's one of the goals, yeah. It's pretty good. Now, here's the thing. That's all relative, though. Pretty good. I mean, it looks like it's 4 off. We'll see here. I went out the data on this. The current data is right here. CO2 now. It's 389.69. 389.69. So we can have two conclusions. Is that the number we got on our prediction? No. It's not. Okay, it's pretty good, but you could also make the case that 5 is pretty significant. But it's not bad, right? It's not saying the parts per million is 100, right? That would be worse. Everything's relative, right? So because we're not exactly right, that tells us a few things. What's one thing it tells us?
Something's
It's
changed.
not linear, it's going like this.
Maybe not linear. Sure doesn't look linear. What else?
Something's changed.
Something's changed. Something's changed. So if it's not a linear relationship and something's changed, what will we need? Instead of a linear model, we'll need something else. Are there other models in your calculator? Absolutely. So if you go down here and you go back to stat and then calc, what do we want to try next?
Quadratic.
Let's try quadratic. That's modeling it as a quadratic. Let's do quadratic and make sure we put it in as y1. Very helpful. And we graph this. Is it going to look very different? Not really. How good is the resolution on your calculator?
Not very
Terrible. So let's see what this one projects. This one predicts 386. Is that a little better? It's a little better. The bigger question, though, is this. Let's see what model would have been the most accurate. Okay, if we did quadrag, that's closer to the actual data than linear reg. Well, let's try cubic reg. Let's see what happens here. If we try cubic reg, stat, calc, cubic reg, it's a cubic function, that's fine. Vars, y1, enter. What's the, oh, sorry. So it did it. So now we need to do y1. What's the problem now? Went over. It jumped over. So it looks like the cubic isn't as accurate based on what it should actually be. So this is cubic. Now here's the thing, though. This is all still subjective, still based on our opinion. Is there a mathematical number that tells us conclusively how accurate a model is? Has anybody done regression analysis before? Let's look at what the calculator told us. There's a bunch of numbers there. It gave us the A value, the B. Those are the coefficients. Has anybody seen this thing before?
Yeah.
R squared. What is that? What's it called? There you go, Fury. Very good. It's the R squared is called the. Yeah.
What about your
Isn't it only accurate?
Hold on. I'll tell you in a second if it's not coming up. The closer to 1, the better.
What's the difference with that?
So, correlation coefficient. I'm sorry about the crappy handwriting right now. The closer to 1, the better. That's what you're looking for. So if we go back and look at this, in general, is that a pretty good correlation coefficient?
Yeah.
In general, for those of you, that's pretty good. Do you normally see that? That's pretty good. Our linear one was actually very close to that. In actuality, when I've done this out, the correlation coefficient for the cubic is actually better than it is for the quadratic. But that doesn't mean it's going to model the future data any better. It just means for the data from 80 to 98, it was better. Doesn't necessarily mean it's going to be better for the future, because as we know, it's probably just going faster and faster and faster. Yes, exactly.
The variables change.
Now, here's the thing. When you did this, some of you probably didn't have R squared come up. Did that happen? If R squared doesn't come up, I'm going to clip this into your notes right here. There's a great website that has a list of common, I emailed this to everybody, common TI-83 problems, and this is a great, great website. If there's no correlation coefficient, you need to run this program right here. It's called Diagnostic On. It's off by default for some reason. If you go to Catalog, which is down here, second catalog, you need to go down to D. The fastest way to get to D is to press alpha and then the x to the negative, it's the D. It'll jump down to D. You just go to diagnostic on. You run that once, and that's all you need to run. Once you run it, anytime you do any of the regressions, except for one of them, and I'll get to that in a second, you will get a R² value. So this is a way, if I ask you what is the most accurate model, you pick the model that has the R² value closest to 1. Got it?
Can it be over 1?
No, I don't think you can ever jump over 1, no. Negative 1 to 1, exactly.
1 means like
100%, which means, oh, awesome. Sinusoidal regression does not generate an R² value, and we'll talk about that later. But just so you know, if you do sinreg, it won't give you sinreg, it won't give you an R² value. So getting back to real life situations here, and the address for this, I already sent it out, but I'll put it here again. Here it is. Common TI-83 problems and solutions are right here. Very helpful. Right here. Very helpful. Very helpful. So let's look at another data set. And here's your present.
2011.
What are they? The name of the stock?
The price.
The price, right. And it's by how often is the sampling?
Every like other day.
Nope.
Or once a month.
Once a month. There you go. Once a month. So what you're going to have here is the following. I'll tell you in a sec. If you want to get this data in digital form, the links are right there. We're going to focus on 2 columns. What's one column we have to use if we're going to do R or I just wrote it down as I said it. We're going to have to use the date. We're correlating the date to something. Which column are we going to use, do you think? Which one? What? Okay, we have an X coordinate and a Y coordinate. So what's our Y coordinate going to be?
Price.
Okay, be more specific. All of those are prices except volume. Close would be a very good guess. Close is close to it. It's not close. Edge close. Anybody know what ADJ close means? It means adjusted closing. Adjusted closing is stock market's open for. It's not open 24/7. It closes, it opens, it closes, it opens, right?
10 to 4.
10 to. It's something pretty limited. It's pretty surprising, isn't it?
Yeah, it's 10 to 4.
But after 4 p.m., can something happen to the company?
Yeah.
They can make decisions that change the value of the company. The adjusted closing price is an analysis done after closing. I don't know what specific time, taking in regards to anything that happens to the company. So if you're looking at historical data, it's a very good thing to look at. Because if you don't look at closing, if you don't look at adjusted closing, you could get closing price, but then something major could happen before the stock market opens the next day, and it wouldn't be accounted for.
They all look pretty much the same.
There are, well, the dates are going to be the same, but the values are going to be very different.
I mean,
For example,
between adjunct closing,
Look at the
close.
2000.
oh yeah, they're going to be very, 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 very close. Unless there's something catastrophic, exactly. So the second part of your homework, well, it doesn't matter what you call first and second. First part of your homework is going to be, so we're looking at date and adjusted close. First part of our homework is going to be this. I want you to analyze Apple and Google stock. I want you to take a look at it and analyze it. The only thing I want to tell you is look at it in pieces. What do I mean by that?
Break it up by a year.
Maybe break it up by year, 2 years. What's the challenge in looking at all the data at once? There's 2 big challenges. One, how much data did I give you? There's a lot of data. First, there's a lot of it. Hard to enter all of it. What's the second thing? What do stock prices do? They fluctuate like crazy, right? Are our models going to be good enough to model the whole crazy roller coaster? No. We might be able to model parts of it. Your goal is to try to find something interesting. Predict something. Let's see what you could find. You could look at the big picture, but just remember, looking at this big picture, it's going to go, it goes up and down, up and down, up, way up. It's very interesting. So if you want this data, you can go to those links, which will be in your notes, and you can get the raw data. This is just an Excel file that you can generate. It's a Yahoo site where you can go to any company, go to historical pricing, and then you can tell if you want the daily pricing, the weekly pricing, the monthly pricing, for what date range, and you can export it as an Excel file, and then do whatever you want in Excel. Yes? I want you to do anything you want with it and tell me something interesting. It's totally up to you.
Oh, previous one.
Yes, free response.
Okay.
Tell me something interesting. For what? The two things, date and adjusted close. That's what you're analyzing.
What if these notes are going to be up by some?
They're going to be up in about 10 minutes.
At least once a year, right?
At least once a year. What? Oh, there's that ties into other things. But do you understand what you're doing for homework? In addition to that, homework packet number 3, which is what I just handed out to you, numbers 8 through 11. Those are all linear relationship questions. Okay.